Hi everyone, I'm Bilal, and along with my colleagues Will, Drew, Noel and Bill, we're excited to be showing you our app, Linkuistix. Linkuistix is a word association game that is powered by AI and is great for improving your vocabulary. So be ready to type fast and to think faster. Linkuistix is written in JavaScript with Node.js used as our runtime environment. To integrate machine learning into our project, we implemented a pre-trained model from TensorFlow. The Universal Sentence Encoder model codes text into high-dimensional vectors that can then be used to determine semantic similarity between different sets of words or phrases. Each word is assigned a score based on variables, such as the word type, whether a word be an adjective or verb, or whether or not the word is a plural. From these scores, we are able to determine how words are associated with one another and power the logic of our game. As the model is trained and optimized for greater than word length text, Linkuistix players can even enter inputs like phrases or short paragraphs. But maybe don't do that if you're gunning for the top spot on our leaderboard.
Another new technology we used in Linkuistix is Google's Firebase services. Other than handling user authentication, we used Firebase Firestore for our database. So, what did we need our database for, and how do we use it? The only thing being saved besides user authentication is a score for the purpose of a leaderboard system. When you create an account, a new document is added to our users collection. This document contains the email and username you are signed up with, as well as a unique UID that is created through our user authentication. When you finish the game and are signed in as a user, a new document is created in the scores collection with the score the user got when that score was created, the username, and the UID. On our leaderboards model, we are just mapping through all of the scores and ordering them in descending order, then truncating them so that only 10 show per page.
One of the design choices we made with this project was to use Pixie.js throughout game development. Pixie is a rendering system that uses WebGL to display images and other 2D visual content to the screen. So by simply using JavaScript class syntax, we were able to create objects that inherited properties from Pixie elements. This meant that all through development, we were able to focus on the game's features and functionalities rather than the logic necessary to manage and display content on the screen. Also, after spending some time with TensorFlow, it was obvious that was going to be resource intensive. And some of the features that distinguish Pixie from other web-based rendering solutions is speed and performance. So with that, we had the foundations for our game. TensorFlow would be the brains behind the operation, and Pixie would help manage the interaction.
Because the TensorFlow calculations are time-consuming and processor-heavy, running the word embeddings alongside the Pixie animations caused both the animation and the tensor embeddings to run extremely slowly. This resulted in stuttering and lagging gameplay, and a hefty delay before the first round started. This is due to JavaScript's single-threaded nature. Only one thing can be done at one time. We needed to find a way to run the TensorFlow models in the background while the Pixie animation and user interface kept running. Our solution was to use web workers, which is a technology that allows us to run the computationally expensive TensorFlow embedding on a separate processor thread, freeing up the main thread to run the animation and game UI. And since TensorFlow is no longer competing with the animation for the CPU and GPU during embedding, it is able to embed the words much faster. It's a win-win. Once we adjusted our code to work with the web workers, we were able to get the game to run much smoother and faster than if we had kept it in the single-threaded environment.
At the beginning of our project, we decided we wanted to make a web game, and we looked into what technologies would best fit our project. We had an exploration phase where we built demo games, animations, and images in React.js, Pixie.js, and Three.js with either their vanilla JavaScript versions or React versions. Our mindset for the project was to create something beautiful that we could all be proud of while still pushing ourselves to learn new frameworks and technologies. With that in mind, we purposely chose unfamiliar tech that is better suited to the goals of our project rather than familiar technology that might have worked but maybe not as well. And this was our biggest challenge with the project, learning an unfamiliar tech stack while creating a fun and engaging game. Every part of this project pushed us and made us grow as developers. With these new technologies, we created a website that is a single-page application where we have a Pixie canvas with React components that overlay it. Combining these two frameworks was easier than we all expected, and we feel creates a great visual and gaming experience for the player. We are extremely proud of our work and happy to present Linkuistix to you.